My name is Yusuf Chitao, and I am pleased to present my project, Sense of Space, the neuro-architectural art that shapes human experience. This project is my entry submission for the prestigious Academy of Neuroscience for Architecture Design competition. I am a graduate student at Cyprus International University, and this project was guided by Associate Professor Dr. Ehsan Reza. Through this work, I explore the integration of neuroscience and architecture, focusing on how sensory design and spatial dynamics can enhance human experience.
In the heart of architectural innovation lies a challenge that merges science with creativity. Welcome to a journey where the future of neuroscience and architecture converges. The John P. Aberhard Student Design Competition honors a visionary in the field, encouraging innovative designs that integrate neuroscience and architecture. This prestigious competition, held on the iconic Salk Institute campus, challenges students to create spaces that enhance human experience through scientific understanding. Architecture and neuroscience, two disciplines, one vision. By merging these fields, we create spaces that not only serve but also enrich the human experience. This design focuses on two critical aspects of this integration: sensation and perception, and movement. This project begins with an in-depth exploration of the neuroscience behind sensation and perception. By understanding how the human brain processes sensory information, we can design spaces that optimize these experiences. Sensation involves the simple detection of stimuli by our sensory organs, while perception is the complex interpretation of these stimuli by the brain. Movement, on the other hand, explores the relationship between architecture and human navigation. By analyzing how people move through and interact with spaces, we can create intuitive pathways that encourage exploration and activity. This design facilitates smooth transitions between different areas, promoting both physical and cognitive well-being. This understanding guided the design process, allowing us to create environments that are both stimulating and calming, enhancing occupants' well-being and engagement. The inspiration for this design begins with the most fundamental elements of the human brain, neurons and their intricate connections. Neurons communicate through electrical impulses, creating a dynamic network of pathways that underlie all cognitive functions. This biological feature is the cornerstone of our concept, guiding the development of the design from abstract ideas to tangible form. In the early stages, the design focused on the complexity of neural networks, examining how neurons fire and connect to transmit information. This process of neural firing, with its rhythmic pulses and branching pathways, inspired the design that reflects these organic patterns. The initial sketches were a direct abstraction of these neural connections, capturing the fluidity and interconnectivity of the brain's architecture. As the design transitioned from concept to form, the essence of neural activity was integrated into design. The building's layout mirrors the network of neurons, with interconnected spaces that facilitate seamless movement and communication. Just as neurons link to form complex networks, the design integrates various functional areas through fluid, curved pathways, creating an environment that encourages exploration and interaction. The exterior of the building is a visual metaphor for neural connections. The flowing lines and organic shapes represent the branching dendrites and axons of neurons, while the structural elements mimic the robustness of neural pathways. This organic form not only pays homage to the neural inspiration but also ensures that the building harmonizes with its natural surroundings, much like how neurons integrate into the brain's ecosystem. By integrating the principles of sensation and perception, and movement, the building's flowing, organic facade and dynamic interplay of forms connected by curved circulation pathways, engaging all senses and creating a constantly evolving environment. Tactile surfaces and acoustic treatments enhance sensory richness, ensuring the space is seen, felt, and heard. The layout, inspired by neural pathways, features interconnected spaces that promote fluid movement and interaction, mimicking the natural flow of neural impulses. Wide, curved corridors and open communal areas facilitate smooth transitions and social collaboration, reflecting synaptic connections. Sensory gardens and biophilic elements provide moments of respite, promoting well-being. In order to respect the Salk Institute's brutalist aesthetic, the design blends raw materials with modern, organic shapes, creating a timeless fusion. This project attempts to bridge a gap in interdisciplinary design, where neuroscience and architecture combine to create functional, inspiring spaces that enrich sensory and cognitive experiences. This design for the community center at the Salk Institute seamlessly integrates these neuroscience principles. The building's form is inspired by the natural flow of human movement, with sweeping curves and open spaces that invite exploration and interaction. The facade maintains the brutalist aesthetic of the original Salk Institute, respecting its historical context while introducing contemporary elements that enhance its functionality. The event space, a core feature of our design, is a versatile area that can adapt to various community needs. Its layout is influenced by sensory design principles, with adjustable lighting and acoustics that can be tailored to different activities. The exhibition arc showcases the collaboration between architects and neuroscientists, highlighting how scientific research informs and enhances architectural design.